Okay, so let me talk about problem one. So problem one says a magician has four-sided dice whose faces are labeled as follows. Um, so like I'm not like writing it down. And the magician randomly pick one of the three die without showing the audience the die he picked. He rolls 6 times and get the sequence. I want to using maximum likelihood method to predict which die the magician picked. So remember like before, if there's only like one measurement, we're doing the likelihood of theta given that specific measurement, which is defined to be the probability of that measurement given the parameters theta. In this case, theta are like what kinds of die. And then we can calculate the probability. The only difference between these and the previous discussion's problem is that we have multiple measurements. So so specifically we have 6 measurements. So we're like doing a disjoint probability. So the disjoint probability is basically a lot of variables together forms a probability distribution. So in this case, we are specifically giving that the likelihood of theta given 6 measurements, which is equal to the probability of 6 measurements given theta. So because each measurement is independent, and that's very important. Each measurement is independent. So like we can separate the probability into the probability of measurement 1. I'm just like writing x1 as measurement 1 times the probability of measurement 2 times x3 times x6. So that's how we like do the measurement. And then we look back at theta. So theta can either be a red die or a green die or a blue die with corresponding values on it. So we look at the likelihood of we first look at, like, for example, theta is a red die, given the result that the measurement is 1, 2, 1, 3, 1, 3. And that equals to the probability of x1 equal to 1, given that theta is red, times x2 equal to 2, given that theta is red, times x6 equal to 3, given that theta is red. So then we look at the red die, like it has like the red die. It has 1, 1, 2, 3. So given that it is a red die, it shows up 1 with half of the probability. It shows up 2 at fourth of the probability, and then it shows up as 1 again, so that's half. It shows up as 3, so that's 1/4, and then it shows up 1, that's 1/2, and then it shows up as 3, that's 1/4. So that's exactly the probability, the likelihood for the die is right. That's 1/256. And then we do the same thing if theta is a green die, and we're getting the result of 1, 2, 1, 1, 3, 1, 3. So that's the probability of x1 equal to 1, given that the die is green, times the probability of x2 is equal to 2, given the die is green, times x6 is 3, And then we just look at the green die. It is 1, 2, 2, 3. So it has 1/4 to get a 1, 1/2 to get a 2, 1/4 to get 1, 1/4 to get 3, 1/4 to get 1, 1/4 to get 3. And that's 1/2048. And then similarly, we do it on the blue die. And then we will get the result of 1024. Because the maximum likelihood is the maximum of the likelihood. So we're finding like which of these three values are the biggest. And it turns out the right die is the biggest. So we're to predict that magician picks the right die because that's the highest chance to get the result of a sequence of 1, 2, 1, 3, 1, 3. But like this problem is a pretty like discrete problem. I mean, instead of saying it's discrete, like I mean, just this question is very very specific to certain scenarios. It doesn't show the randomness, like random variable of the theta or like the parameter itself. So that's just giving you an intuition on the difference between destroying probability distribution and the probability distribution itself. Actually, there's like a whole lot of like topics on destroying probability that like our class didn't focus on, but like you're interested to like do more like study on destroying probability. So with that in our mind, I'm gonna like do a review on the lecture. So in the lecture, we're talking about like maximum likelihood for multiple measurements. And but it depends on like the random variable for that measurement. So maybe I will do like a summary for problem solving. So say we have x1, x2 up to xn measurements, and they are IID. That means like they are the same distribution and they are independent of each other. How do we get the maximum likelihood? So at the first step, you need to write out what you are doing. So like you are writing out, you're doing that, you're taking the maximum likelihood of x1, x2, xn, or you're taking the maximum likelihood from data, given that you are doing like a lot of measurements, and that by definition is equal to the probability of x1, x2 up to xn given theta. And it kind of like and then another equation hold because of the independence. Like remember, IID is independent and identically distributed. So because of the independence of this variable, we can write the probability as if it is x1 given theta times x2 given theta times xn given theta. And then because of the identically distribution and the random variable itself, we can plug in the probability distribution for each of the probability. Yes. So I guess, yeah, this should be like step 2 over here, where we get the result. So that's all for like setting up the equation. So at this moment, you are setting up your likelihood equation. And then right now, all you need to do is to algebraically find the maximum. So the way you find maximum is, so then you are moving forward to find the maximum. And the way you find maximum is exactly the same thing as what we did last time. You're finding the first derivative of the function L to find critical points. And those critical points are either maximum or minimum. And a easier way to find, like sometimes easier way to find is to take log of the function and set up this to 0. So you can also find the first derivative, the critical point, or you can just directly take the derivative if that's easier. And then, so on the third step, you are finding the critical point, and you want to like among critical points, you want to find the one that is global maximum. So how do you do that? The approach you are doing here is you take second derivative and plug in critical points. There can be like multiple critical points. So if negative, like if the value of the second derivative, so second derivative taking critical points, if that is less than 0, that means there is a local maximum. And then you need to like go through all local maximum. Let's say M1, M2, and up to MK, and find the map of M1, M2, MK. So that's your global maximum. So like all questions can be solved in these 4 steps. These first 2 steps are setting up the equation, and the last 2 steps are solving computationally. Yes, and some highlight on the, so actually the most important thing is like you set up the equation, because like the way you're finding the computation is essentially pretty much the same. Sometimes you take log, sometimes you take first derivative directly, but the computation work is almost exactly the same. So as for the first 1 and 2 steps, you just need to be aware of so like you are given ID already, so you can like take the disjoint independence relationship together here. But I just want to make sure that all of you guys understand how each step comes from the previous step, how the equation holds. So I'm just like listing the reason why all those equations hold, so that if you are given like something you are never seen before, you can just calm down and say like if this equation holds and why is it not hold and why is it hold. So that's the independence. Another important thing is the random variable itself. So you need to be very clear of which random variable they are. So like let me and like one thing that you may be confused is like sometimes it can depend on two parameters instead of one parameter. So for example, in the lecture, the professor went through the normal variables. Remember, normal variable is kind of depends on both mean and SD. And how do we handle this situation? So maybe like we can redo the example she mentioned in lecture. So in the lecture, she mentioned that there will be like multiple measurements for a blood pressure or something like that. And there's x1 up to xn, and they are IID, normal random variables. And then the way we find the maximum likelihood is so maybe like the first side question is that we're given SD but unknown mu. And how do we solve this problem? We first following my first and second step to set up the equation. So remember, if we're finding the L data given x1, x2 up to xn, it's just equal to, by definition, the probability of x1, x2 up to xn given theta, and it's just equal to probability of x1 given theta times x2 given theta times up to xn given theta because of the independence. And then what is each step? What is each probability? Remember, like the probability density function for a normal variable is that 1 over square root of 2 pi times sigma times e to the negative x minus mu squared divided by 2 times sigma squared. So that's the probability here. So for each of the xi, so for each of the x, we're plugging in the probability here. So that's square root of 2 pi over 1 times sigma times e to the negative x minus, so x1 minus mu squared over 2 sigma squared times the second one is x2, so it's 1 over square root of 2 pi times sigma. So this is like the first p, and then the second p is e to the negative x2 minus mu square over 2 square squared, and times a lot of steps. And because like this part are all the same for each of the probability, and we have n parts of that, so we can rewrite it as the square root of 2 pi times sigma over 1 to the nth power times e to the negative x1 minus mu square over this times e to the negative x2 minus mu square over 2 sigma times blah, blah, blah. So that's like after step 1 and step 2, we successfully set up the equation. And remember, like what we have here is that we are given the sigma and we're unknown mu. And like x1 to xn are always given because they are specific measurements. This distribution is specifically for normal distribution. And in the discussion, you will find a lot of different types of problems on different distribution. And the normal distribution, from like I think it is the hardest, so that's why I'm like going it through. So what am I? Oh yeah, we're given mu, but we don't know sigma. Yeah, we are given sigma, but we don't know mu. So these are given, and each xi are given. So the only unknown here is mu itself. So we treat the whole big thing as a function of mu itself, and then we do a derivative. Like we want to like find the maximum, and the maximum, because the only unknown is mu, and the mu kind of depends on it kind of like the maximum kind of depends on mu. And the way we do that is basically we take first derivative on this big function. And how do we like take first derivative? Like it's kind of hard to take first derivative, right? So instead we use the log method. We first take log of that function. So we take log of this whole function. Remember, like log of terms multiplied together is just equal to log of the term plus log of term plus log of the term. So it's just equal to log of 1 over square root of 2 pi times sigma to the n plus log of e to the negative x1 minus mu square over 2 sigma square, and so on. Let me just like copy down from here. So this by definition of log is just equal to, so remember like log of x to the n is equal to n times log x. So I'm doing the same thing here. That's 1 over 2 pi times sigma plus, remember like this is natural log, the base is e. So that is directly equal to negative x1 minus mu square over 2 sigma square. And the second term is just negative x2 minus mu square over 2 sigma square. And then we were to take derivative. And because we are like unknown mu and known sigma, so we can like treat this term as constant because this is known. And we also like known the denominator here. So in fact, after taking the derivative, we're just like getting like something like so like the first term equal to 0, and the second term is just like negative 2 sigma square over 1 times the derivative of this. So this derivative. So this derivative is equal to 2 times x1 minus mu times negative 1. And this term is actually just 2 times or sigma square over x1 minus mu. So if we sum all these terms together, that will actually be sigma square over x1 minus mu plus x2 minus mu plus blah 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 plus xn minus mu. And we want this first derivative to be 0. And we figure out the mu is actually equal to x1 plus x2 plus up to xn divided by n. So like, so the whole thing might be complicated, but like actually the algebraic idea is pretty simple. Yeah. So that's when we unknown mu but known sigma, and we can do the same computation again when we known mu but unknown sigma. So that's actually like just for the normal distribution, and there are like different type of problem for other problem as well. So maybe like we can take a good look on problem 5 on the discussion worksheet. I'm not like giving you too much time to. I'm not giving you time to read it through, or like I'm giving you the time to read through, but I'm not giving you time to do that. So like let's just read together. Suppose X is a normal random variable with unknown mean, and an unknown standard deviation. You randomly pick a sample 4 times and get the value. So that's x1 equal to 3, x2 equal to 4, x3 equal to 6, and x4 equal to 7. So we want to use maximum likelihood estimation to estimate mu and sigma given this data. And for this specific problem, I'm just like doing what I just mentioned before. We're setting up L, but this time L is depends on both mu and sigma given x1 to x4. And we know that this is the probability of x1 given mu sigma times x2 given mu sigma times x3 given mu sigma times x4 given mu sigma. And each of the probability, because we know that this is a normal variable. And the equation for normal variable is sigma times 2 pi, square root of 2 pi, or 1 x 1 minus mu square to 2 sigma square. That's exactly what I have before. And we're just like timing it 4 times. Instead of n times, we're just doing it 4 times. And then like we can rewrite this equation to be, because these are the common terms. So we can rewrite it as sigma 2 pi over 1 to the 4th, because we are only having 4 terms right now, times b to the negative x1 square mu square times e to the negative x2 minus mu square over 2 sigma square times x3 and x4. I'm just skipping that. And then right now, like we successfully set up the equation. And what we need to do next is to find the maximum. But like the maximum kind of like maybe like, so like if you want to find the maximum, obviously need to set the first derivative equal to 0. And obviously it's hard, so maybe like we should take the log of our random function to simplify it. So after taking the log, let's just log of this whole equation over here. And remember that that equals to log plus like each term. Maybe I should write it 1 over sigma square root to the 4th e to the negative x1 minus mu square of 2 sigma squared. And this log is just 4 times log sigma 2 pi over 1. So we are using like log of x n is equal to n log x. We're using this fact here. And because this is base e, we can just get the result directly. That's x1 minus mu square over 2 sigma square plus the negative of x2 minus mu square to sigma square. And same thing for x3 and x4. So now we are facing a problem because we have 2 unknowns. There are sigma and mu. And how do we handle that? So actually, like that's the idea of multivariable calculus, that we need to like. So the idea of multivariable calculus is to like treat one variable, like say not variable, just like 2 variable calculus maybe. Treat one variable as constant and do work on the other. So in this case, where, for example, we can first treat sigma as constant. So and mu as variable. So we first take this derivative on this equation with respect to mu. So now we are taking like sigma as constant. So the first term becomes 0 after taking derivative. And the second term is just what I mentioned before, taking the derivative as 1 plus -2 squared x1 minus mu, x2 squared minus mu squared, taking derivative, and we have a lot of x3 and x4 later on. So we can kind of like get the 2 sigma squared out, and inside it will be 2 times x1 minus mu times -1 plus 2 times x2 minus mu times -1 plus . And we say that we are setting this first derivative equal to 0, and we say that after the computation work, this has to be 0, and mu has to equal to x1 plus x3 plus x2 plus x4 over 4. And we are given that x1 is equal to 3, x2 4, x3 6, and x4 7. So we just plug it in. That's just 3 plus 4 plus 6 plus 7 over 4, which is 5. And the second part is that we're treating mu as constant and sigma as variable. And how do we do that? We went back to the equation here. Let me just copy and paste it here. So that's the equation we had before. And we are like taking derivatives on with respect to sigma, because like sigma here is like a variable. And how do we do that? Direct that to sigma. So like each of the term here becomes, so it's just like x1 minus mu squared over 2 times sigma squared over 1. If we were to take this derivative with respect to sigma, that's just like -2 times sigma squared, negative sigma cube times negative x1. So we're like treating this as a constant. Like I don't really understand why we're talking about this. Like if you don't have too much knowledge on multivariable calculus, but like this on the discussion worksheet, and I would suppose that this is something that in the scope of our discussion. So that would be x1 minus mu to the square times sigma to the -3. And the first part is it's just I forgot how to calculate that. It's just we can treat that as ln of sigma over 1 times 2 pi square root over 1. So that's equal to ln of sigma -1 plus ln of 1 over 2 pi. Of course, 4 times this. And if we were to take a derivative, we just, so that's 4 times this. And remember, like, we can like get the negative 1 out, plus 4 times ln of 1 of square root of 2 pi. If we were to take the derivative with respect to sigma here, that's just negative 4 over sigma. So that's the derivative for the first term. That's the derivative of the second term. Similarly, for the third term, it will be x2 minus mu squared times sigma to negative 3. So at the end, we get negative 4 over sigma plus x1 minus mu squared times sigma to negative 3 plus x2 minus mu squared times sigma negative 3 dot dot. And we're seeing that this equals to 0. We're basically solving this solution. And before, like, so right now, because at the previous part, we calculate mu equal to 5. So we plug in mu equal to 5 here. And then there's just like algebraic work to get sigma. And at the end, you will get sigma is equal to, like, sigma squared is 2.5. So sigma is square root of 2.5. Because like the solution skips a lot of steps on the problem 5. So like I would assume that a lot of you might have difficulty on like walking through problem 5. So if you didn't get what I'm talking here, just like after the discussion, go look at problem 5 and work it directly by yourself. If you face a difficulty, come back to the video. I will upload this video on YouTube. Yeah, and I think I can everything in very detail, but probably a little bit fast. But like if you have time, just pause the video and understand each step. You will figure it out. The other problem 2, 3, and 4 are all not hard problems. You can like definitely figure it out by yourself. And I will also like go through one of the problems later in the discussion. Yeah, this is just like the concept is not hard. It's just like algebra is hard, and sometimes it's hard to understand, follow each step. So whatever, like I will upload the quiz problem, and you're gonna do the quiz now. And let me know if you have any problem right now. Okay, the quiz should be up on Bcourse right now. So it's under the folder files and quizzes. There's quiz 11 on 202. So do the quiz, and it's due at 10:47. Yeah, it will be strict due at 10:47. And I will take attendance after you all submit your quiz. Let me know if you can't access your quiz. Yes, you are allowed to use calculator. I mean, like, I will never know if you are using calculator or not, but like, yes, you are allowed to use calculator. But I don't think you have to, like, you have to use calculator. So you're fine to use calculator. On the actual exam, I don't think you are allowed to do that. Yeah, and just to clarify, like you're allowed to use calculator, but you have to write like the very last step of your equation, like without using the calculator. So like you are using the calculator just the very last step of computation, and to see your like final result without like calculating. And you should like see your equation. Yeah, it's okay if you don't use the calculator. I mean, it's okay. Yeah, and the questions are not that hard, so I don't think. Yeah, I mean, it wasn't meant to like trick you, so it should be good. Yeah, just like a lot of students are asking me questions, and just like clarify that the quiz itself can be done in 10 minutes. So if you think you are doing a lot of stuff that is impossible to finish in 20 minutes, that means you're probably doing something wrong. Like the quiz can like very easily done in 10 minutes. I mean, probably not very easily, but like it's a 10-minute quiz. Yeah, students from my last section also have the same problem of not letting you select the problems. So I guess you can just like upload your solutions. Um, yeah, I mean like just try to like match it up. Like some of you might have trouble like matching the pages. So I guess you're fine with that. Just like submit as long as you're submitting your solutions. I will figure out why is it like that. Yeah, remember you only have 1 minute on submitting your answers. So now it's pretty much a good time to do the submission. I believe I'm still missing 5 or 6 submissions. Like this time I set up the deadline pretty sharp. I'm not like accepting a late submission too much. Okay, I think that's it. So I'm gonna set up a poll. So for your discussion today, you have 2 minutes to answer the poll. Okay, you have 10 more seconds to finish the pool. And I will close the pool at 2 minutes. Like I will close the pool in 3 seconds. And pool. Okay, so most of you get the correct answer. The solution for the first problem is false. And the reason why it's false is because on the interval, you can find a critical point, but the critical point can be either a minimum or a maximum. If there's only one critical point, it can be the global minimum or global maximum, not necessarily to be the global maximum. But for most of the distribution, we look at the maximum likelihood problem. There will usually be a maximum, a global maximum. Like the critical point just directly goes to the global maximum. Because the reason why we're doing the likelihood, the maximum likelihood is because we're finding the maximum of those of such probability. So the function should behave like it has a maximum. And for the second problem, everyone gets correct. That's true because that's exactly how we define the disjoint probability distribution. And like in fact, I didn't like clarify that question very well. I should write it as x1 to xn are independent. So like yeah. So if you always need to check independence before writing down this equation. So moving on, let's look at problem 4 in our discussion. I will give you 3 minutes to work on problem 4. Okay, so time's up. Let's go through the solution for problem 4. Let me first check if my screen stuck or not. Okay, stuck, it's frozen. That's what I expected. So remember, like the first example, the normal variable is the hardest question. Like the normal variable is the hardest question. It's the hardest. Like that's the thing we discussed before. It's the hardest. All the other distributions are easier than normal. Like for example, this exponential random variable. Question number 4. This exponential random variable only depends on unknown parameter c. Remember, like exponential probability distribution is like c times e to the negative cx. So it only depends on an unknown c instead of like mu and lambda, mu and sigma. So we follow the 4-step procedure. The first thing we set up the algebraic notation that we're finding the likelihood of the unknown parameter c given x1 to x5. And this is defined to be the probability of x1 to x5 given c. And because of the independence, the disjoint probability can be written as x1 given c times x2 given c times up to x5 given c. And then because this is our exponential distribution, we plug it in so that c times e to the negative cx1 times c times e to the negative cx2 times times c times e to the negative x5. And we simply we combine terms together. So we have like c on all 5 terms. So that's c to the 5th times e to the negative c1 minus c3 minus c4 minus c5 cx5. So that's c to the 5th times e to the negative c x1 x2 x3 x4 and x5. So now we are done with setting up the equation, and we're moving to step 3 to compute the result. And then to compute the result, we need to set the first derivative to 0. But apparently this is hard to calculate. So instead, because we have like the e to the powers, so instead we take a log on the function. So the log of L is equal to the log of c to the 5th times e to the negative c x1 up to x5, which not L, is log. So which is log of c5 plus log of e to the negative c x1 plus up to x5. This, by definition of log, is 5 times log of c. Actually, it doesn't matter, it's a constant. This is negative c times x1 plus x2 plus up to x5, because the base here is e. And then we're setting, no, it's not first derivative. It's just taking a log. And then we need to take the derivative of this log, which is 0 for the first, oh, wait, it's not 0, it's c. So it's 5 times c over 1 plus the negative of x1 plus x2 plus x3 plus x4 plus x5. And we're setting up this derivative equal to 0. And how do we calculate the c? So it's times c on both sides. So that's maybe we move that first. So c 5 over c is equal to x1 plus x2 plus x3 plus x4 plus x5. So c is equal to 5 over x1 plus x2 plus x3 plus x4 plus x5. And remember, we're given x1 to 5 in the question. These are the value of 25, 30, 33 things. So c is equal to 5 over 25 plus 30 plus 33 plus 27 plus 31. which is 5/146. Yeah, and that's the end of problem 4. So um like in the solution, it doesn't like show you why, like theoretically you should also like perform a second derivative test. So theoretically you should take the second derivative here to get um more specific result. But like I guess the solution stack is fine, so you should be fine. But if you want to do it more precisely, you should take the second derivative and plug in a equal to 5/146 to see if the second derivative result in a negative number. If it results in a negative number, that means it is concave down. That means it is a maximum. Yeah. So I guess that's all for today. I will stay here for 1 extra minute to answer the possible questions that you may raise up. Otherwise, you are free to leave. Okay, for those who are still staying, if you didn't ask a question in the next 30 seconds, I will end the meeting. All right, I will end the meeting now.